So let me talk with you about classification of systems of equations. We've already talked about all three kinds of these systems, but we never used the vocabulary that you may see in some of your homework problems. So the first kind is intersecting lines. And so we saw those, and we said that if lines intersect at one point, we call those intersecting lines. And that they have a single point solution. These are also called independent, consistent systems. So independent and consistent. Then we saw parallel lines. And we know that parallel lines are lines with the same slope, and they never intersect. So parallel lines have no solution because they have no points in common. And this is called an inconsistent system. Inconsistent because there's no solution. Sorry about the sniffing, but I'm sick. The third choice is the same line. And some books will call this coinciding lines. And these are coinciding because they dwell or coincide in the same place. And it looks like a single line. And a single line has a lot of solutions. It has an infinite set of solutions, but only a specific set of points. Not all points, like this point is not on the system, and this point, and this point, and this point, but only those that are on the actual line, even though they give it as two lines, like 2x plus y equals 6, and 4x plus 2y equals 12. Not this line, but those would be two lines that are exactly the same line, just in different formats. And their solution looks like this: x, y, ordered pairs. So it's the set of all ordered pairs. And then you would write either one. This one looks like, let's see, what is this? It crosses at 4.5 and has a slope of, it looks like it's about 1.5. So y equals 3 over 2x plus, let's see, that's 4.5. That would be 9 over 2. So whenever you have the same line or coinciding lines, the solution to the system is going to be either one of the equations. Okay, now remember, this is not that line. But you'll be given the system as two lines. And I'll work one of each of those in just a minute. And the last one is, let's see. Oh, okay, so that's all of them. This one's crossing lines or intersecting lines are independent, consistent. Parallel lines have no solution, inconsistent. And these are consistent but dependent. Now, I am not going to test you on this verbiage, the consistent dependent or the consistent independent. Instead, what I want to know is that you know that intersecting lines cross at one point, that parallel lines have no solution because they never cross, and that if the equations represent the same line, then you're going to have infinite solutions, and that it's not every ordered pair you have to put one of the equations into the solution set.